the functionality that you can go really low. Obviously, all the security aspects of it sounded really appealing. Like, we didn't want to create this tool in like, let's say, C with Go. If it has like specific functions, it implements that interface by default. With Rust, like, obviously you have like the generic implementation, which I know ironically is more like the .NET days for me. There's always like the little asterisks, the caveats of like, this might not work in this situation. That's one moment for me was like, oh yeah, it's trying to prevent me from making this security mistake because then X, Y, and Z could happen. That curiosity, I think, is important.
Good morning, everyone, and thanks for coming here again for another episode of our Rust interview series. Today with us, we have Benno, who's a principal engineer at Fiberplane. Hello, Benno.
Hey, how are you?
Do you want to introduce yourself to our listeners?
Yeah, my name's Benno van der Miller. Working at Fiberplane for a couple of years now, mostly doing Rust nowadays. Also a bit of management here and there, infrastructure, a little bit of everything.
That's the reason we're going to be delving a little bit into Fiberplane. And I guess before we go into that, which is the interesting part, I think we need a little bit of context to understand what we're actually going to be talking about. So let's start from you, right? You've been in the software industry for a while. You have been doing a variety of things before joining Fiberplane. Do you want to cover a bit your journey as a software engineer?
Yeah, started off from my internship. Started off at a company and then started with .NET. This is back in the days when web forms were still hip, but I learned a ton, stayed there for quite a while, and then at a certain point, one of my coworkers approached me that he was going to start this new startup, and I was kind of getting like a bit tired of what I was doing, so I figured like let's do it, and then we started off creating this CI platform called Worker. Unfortunately, you can't find anything about it anymore almost. It's unfortunate, but yeah, the text there started off with Node.js. Yeah, that was fun. Learned a lot there as well. Like we started off just from the get-go with like a completely new language, or at least for me, new language, new framework, and almost like a new mindset as well. And I think like halfway through, we started to notice some like issues, some things that didn't work well, and we decided to go like, instead of like one monolith, we decided to go into this microservice like architecture using Go at that point. And that was also a lot of fun, like learned so much there as well, like concurrency and just more low level language, like I said, the microservices, but we started using Node.js for the server side rendering. We had gRPC going on there for the microservice talking to each other, and also like exposing that as just regular JSON to browsers. So it was a lot of fun, did a lot of things. Eventually we got acquired by Oracle, worked there for a couple of years. It was also an interesting view, like the industry, interesting people that I work with, some smart people, some very talented people, but eventually I did get the feeling like this was not really going anywhere, as in a lot of like the solutions are really specific to Oracle, which are good, but they don't apply a lot to like maybe outside world. So you learn a very, very, Oracle kind of way of doing things, and that doesn't transfer as much. So at that point, I figured like I was looking for something else. So there's a couple of years into that. Also, doesn't help that I was basically the only person here in the Netherlands working here. So my job security was not great, with my manager working somewhere in the US. Anyway, at that point, the person who I started the previous startup with approached me again. He was going to do something else, and that was Fiberplane. And this time we were like, we need to use like some new language. So we settled with Rust. That was the new hotness at the time.
Right. So you did it twice, and both times with the same team. So the previous startup you did together was in Go. This one instead was in Rust. Yeah. Before we touch on why Rust, let's understand a little bit, what does Fiberplane do? Like, what is the product?
So Fiberplane is a collaborative notebook product. So you can go in there, work with your team, kind of like Google Docs, where you can just like create a document and work on it together at the same time. But we also allow you to investigate your own infrastructure. So we have providers, we call them, for Prometheus, for Elasticsearch. So you can get your metrics and then visualize them in a graph. And then, obviously also visualize your logs, things like that. And then you can, if there's an outage, for example, you can get in with your team, investigate this, and hopefully resolve the issue. And then it also leaves you like with a document that you can refer to later for like a post-mortem or anything that you do afterwards. You can refer back to it, and then you know exactly when things happened, what things, or what people did. And then we're also working on this other like open source tool called Autometrics, and that allows you to easily get like functional metrics. So how many times has this function been called? How many times? What are the latencies? And with that data, like it's very easy to implement it in your like Rust, or we also have Python support and a couple other languages. It's very easy to add these things in there. You get these metrics out from there, and then because they are, we know what the shape of those metrics is going to be. We have this other tool called Explorer, and that allows you to easily browse these metrics, so we can to see all the details that are in there. And even we have also SLO support for that as well. And
okay, so you kind of span the two sides of the divide. So on one side you have a Jupyter Google Docs style notebook, where basically you have the next version of what people usually do. You usually screenshot dashboards and copy paste them into a Google Doc. At least that's my experience. Instead, in your case, it's more like widgets, if I understand correctly. So they're embedded. You can actually go back to Grafana, go back to Prometheus, go back to whatever the source is. And now you're also branching into the instrumentation side. So that's what Autometrics is. So giving people an easy way to produce metrics, which happen to be a format that you understand, so that the integration with the notebook kind of like works out of the box.
Yeah, that's right. Yeah.
Nice. And so you said, what is it, 3 years ago at this point, more or less, we're going to do a new startup, we're going to do observability, and we're going to do it in Rust. Why? What you there?
Yeah, that's a good question. Yeah, it kind of feels like we're always trying to like get this or try out this new language that is, I say the word air quotes, but hip at the time. Mm-hmm. We had the same with Go and Node.js, but for Rust, we were also planning maybe adding like this agent to get like really low level like information, eBPF, like instrumentation.
Can you share what eBPF is for those of us who are not Linux users?
Oh yeah. eBPF is this way of, well, it's a lot of things, but what we were going to use it for is to instrument like CPU usage, all kinds of like super interesting low level details regarding your environment. So memory usage, CPU usage, congestion on all kinds of like places, IO, all of those things. This never really got off the ground, but we were anticipating that we were gonna create something, and for that like a low level language is gonna be pretty great. So we were like, Rust seems very perfect for that. It's super hip at the moment. The functionality that you can go really low. Obviously, all the security aspects of it sounded really appealing. Like we didn't want to create this tool in like, let's say C, which I have like almost no experience with. So for me, that was already like a bit scary trying to create a tool in that and then not make like all the security flaws that you could make. So having that was already for me really great. And we were also looking a bit like, this is back then we weren't really sure what it would mean, but we were also like looking into WASM a bit as well, like monitoring that, what was happening there. But we didn't do anything at the time with it, but eventually we did get around to it, and that really saved us.
So I guess the question now is, what do you actually use Rust for at Fiberplane? So you didn't go into eBPF kernel probes. You ended up building what is de facto like a multiplayer in-browser experience. Where does Rust fit into this picture?
Yeah, so Rust, it almost fits everywhere, like even in the browser to a certain extent. So yeah, obviously we're using it for our API servers. So every request that goes in there goes through some Rust code. And yeah, that's just straightforward and really like it there. We also use it for our CLI tools. So we have like a little companion tool that makes it easy to like do certain things just from the command line. So you don't have to, start up the browser and you can just maybe even like automate things using like bash scripts or whatnot. But then also we're using it as a WASM as a compile target for some of our code. So we have some OT stuff, operational transformation, I think. Essentially, it's also what Google Docs uses for their collaborative experience. So if you send some characters, they will show up everywhere. And if there's conflicts, there's some way that the algorithm will be able to handle it.
How does this, so as a person who is fairly illiterate on like multiplayer experiences, I often hear about CRDTs as an example. How do OTs compare?
Yeah, but what I always tell myself, I guess, is like how data compares that CRDTs are more advanced and they allow for like offline conflict resolution, whereas with OT there there most likely is going to be like one central entity that's going to determine like, oh yeah, these changes were first, so I'm going to apply them. These ones conflict with them, so I'm just going to reject them. So there's going to be this central entity, and for us, that's our API servers.
Basically, loses a bit the distributed aspect, and you have one central point on decision making that says you go in, you don't. This is the state of the document.
Exactly, and like offline support is going to be a bit more tricky because you locally, if you're offline, you can apply changes, but you've no idea if these changes are going to like propagate to the central server. Maybe like whatever you're trying to change has been deleted since by somebody else. So then there's I guess that would also happen with the CRDs. Anyway, bad example maybe, but
that was an aside, but mostly to get a little bit of a grasp on what we're talking about. So how does Rust feed into the OT engine?
Yeah, so we have one OT engine like written in Rust, and that's just a simple crate. That's it's a proprietary crate, so we don't distribute it, but that's being reused on both the front end side, like the browser, where it's compiled as a WASM module, but also on the back end for our API server. So we don't have this situation where we have this OT logic written in two different languages where there's a high chance that one of them just does it slightly different. And then once that happens, then you're going to have this weird like situation where both languages can have like a different view on the world, which is going to be very different. So just having like one language, one code base that's being used by both the browser and the backend, that was really great. We really like that.
So if I understand correctly, you are building this piece of code in Rust, and then you're using it as a library in your Rust APIs, and then you're using it as a WASM module inside the browser.
Yep.
How is the interface between the WASM module and assume what's the rest of the front end, which is probably TypeScript, throwing a guess?
Yeah, so my knowledge regarding what we run there is fairly limited. I'm not that much of a front-end developer. Like I'm guessing like at the previous startup I did some Backbone, so that already shows how far. But yeah, we use another tool called FP BindGen. That's an open source tool, so you can just
is this developed by Fiberplane, or is this a tool from another company?
This tool developed by us, yeah.
Okay.
So there's EAS BindGen, I think it's called, which is a very popular crate, and that's very useful in the situation where you only need to deal with some browser interoperability. So let's say you have your your JS code, and it needs to call into the WASM, and then you get some data out of it, and that's perfect. But we also will get to there a little bit in just a little bit, but we are also running some WASM on the server side. So in that situation, the WASM the JS bind gen was not optimal. So we set out on this journey to create our own operability. So it's essentially just like it exports it exports a couple of functions. So these functions will just maybe let's take a step backwards. Like WASM is pretty primitive in what it can do. Like you can return pointers or rather just a number, and you have this shared memory. So you can't really like create some functionality in your Rust code, return a struct, and then expect that to work in your JS code. So you need to have like some sort of
serialized that basically takes any complex structure and like encodes it into something that can go in and out of about WASM module, basically.
Yeah, exactly. So and on both sides you will have like some struct definitions, those will match. And then in your code, like the tooling around it, I think JS bindgen does this as well, and as does FP bindgen, you just say like, I'm going to return this struct. You put a macro on it, and then it gets rewritten to not return a struct as is, but it's just going to return a pointer to some shared memory. And in that shared memory will be a serialized object that both know how to deserialize. So we're using, I think, message pack, but essentially it can be anything that you want. And once this goes over, the FP bindgen like bridge, the other side will deserialize it and then make it available on that side. So that's essentially what FP bindgen is doing, tooling around that interoperability between, the host environments in the WASM point of view, the host environment and the VM WASM environment.
It's interesting because obviously from an architectural, like technical standpoint, this is a very strong leverage point. Like you can add new pieces of front-end code. Let's say you can add a mobile app if you wanted to. You can add a desktop native experience, and you will be able to reuse basically the same OT engine in every single piece of code, either by compiling it to WASM or by compiling it to, a native extension that you can invoke from Swift, Kotlin, whatever. At the same time, though, and this is based on previous experiences of mine, you're also introducing a language barrier for the folks who primarily deal with the presentation layer. So the people primarily working on the front-end side of the front end. So how the data gets rendered and how the entire experience works. How is that been going, Fiberplane?
Yeah, so that's definitely a bit more tricky because indeed most of, if not all of our front-end developers were very sufficient in TypeScript, JavaScript, but have never really touched on Rust. There's definitely some like barrier to entry, I guess, there. But we also, we do not do everything in WASM, for example. So a lot of like the logic regarding like rendering and code or data organization and all of that stuff. I think we're using React and some other components on top of that. They're still living in TypeScript, but when we do need to interact with, like, let's say this OT thing, you just call out to a function, and if all goes well, like the TypeScript developer doesn't have to touch any of the Rust code. Obviously, if they need to make like a change to it or fix a bug, then they do need to dig into it a little bit more deeper, but hopefully they won't have to interact with it too much. But I do think at this point, most of our front-end developers, they do like Rust to a certain degree.
Okay, so they have some level of experience and familiarity.
Yeah, we just did like some sort of like, internal, like, hey, this is how things work with TypeScript, and this is how you would do them in Rust, kind of thing. I wasn't responsible for that, so I'm not really sure how well that went, but I think that worked out pretty well.
That's an interesting point, which I want to touch upon, which is training and learning, right? So you chose to do a startup in Rust 3 years ago, 2020. there's not a massive market of experienced Rust developer. When I mean experience, I mean professional experience. So folks who have developed production systems in Rust before. That is expanding in the recent years. Obviously, more companies are adding Rust people. These people then are changing jobs, and that flywheel is kind of solving this talent pool problem, but it's not quite done yet. What's Fiberplane's experience with this? Or are you finding either hiring experienced Rust developers, or do you train them up on the job? What's your approach?
Yeah, so I think we especially back in 2020 or a little bit after, I think we were in a really good spot, as in a lot of Rust development revolves around crypto. But when we got a lot of applicants, they were like, yeah, this is great. I want to do something with Rust, but I don't want to do anything with crypto. So we already had this niche where people were floating towards, I guess. Yeah, we have had some people who are way more experience with Rust, and then some people had a little bit less experience with Rust, but then they had for example, some more Go knowledge, for example. So it's always good to have that little bit of mix of different languages as well. You want to have a bit of a diverse group, I guess.
I mean, also you are interacting with the cloud native ecosystem, I imagine, quite heavily, and that's primarily, almost solely, you do need to be able to read that Go code base from time to time, I imagine.
Exactly. Yeah, we did have that course where we have transferred some TypeScript knowledge to Rust, or see how it compares, but we don't really have a rigorous a book or anything. Rust links we always recommend for people getting started, but to be honest, we never had people who had zero knowledge regarding Rust. There was always already some knowledge, that first hurdle of the borrow checker, that was already taken care of.
Okay, so there were either Rust experienced Rust developers or Rust curious enough to have done some nibbling.
Exactly.
At the hobbyist level.
Okay. Yeah, we had a lot of applicants indeed that were oh yeah, I've been doing Rust on and off, for personal project, or just on my own, because my company doesn't want to do it for whichever reason. And then we came across you and we wanted to apply. So that's also, a lot of applicants were like that.
Let's do a little bit of a recap, right? So we touched on where you use Rust. Established you started around 2020. Now, having 3 years and a half, 3 years old code base, Rust, production code base, there's not that many out there. I mean, there are a few, but they're not that many. Do you have any regrets? What's your balance? If you look back and say, okay, we chose Rust in 2020. Are we happy with that? What have you done differently if you knew 3 years ago what you know today?
Yeah, so with Rust itself and with how language is evolving, I really like the if let else guard. Anyway, the one that you can short circuit and I just love it. You don't really know, or at least that's how I am. I don't really know what I want until I see it, and it's I need it. So that was amazing. Those kind of improvements still coming out. That's great. Our own code base, unfortunately, is a bit it is a big monolith, and unfortunately within the code base itself, it's not very well organized, and that's giving us a lot of issues with that's one of the biggest complaints, I guess, with Rust regarding compile times. So fortunately the Rust itself is a little bit slow, but our code organization at the moment definitely does not help, which is unfortunate, and trying to fix that now is such a major undertaking. So if I was able to tell to myself hey, look out for these things, or try to do this already, it's not gonna matter that much in 2020, but in 2023 you will be very happy with yourself.
Is this because it's one big crate, and so that takes a long time to compile? Exactly. That's interesting, because some things are changing around that. I think the news is from 3 days ago. So some background for folks who are using Rust. The way Rust compiler works, there's parallelization on 2 levels. So the first level is cargo. Cargo is able to build multiple crates in your dependency graph in parallel, as long as they don't depend on one another. So usually if you have a dependency graph which has a lot of small compilation units, Cargo can fan out, use all your cores, and that allows it to go fairly quickly. But every single unit inside that graph is generally single-threaded. All the Rust compiler frontend operates on a single thread, which then in the case that Benno was describing, as in Fiberplane, that means that if you have one very chunky crate, which might have, 10,000, 20,000, 30,000 lines of code, that is going to be very slow, because even if you have a 32 core machine, that's just, going to chunk it on one core, and one core can only do so much. Now, I think that has changed. Well, I don't know when this will be published. At this point, I would assume a few months back. In Italy, it has landed a new flag, which is called C parallel frontend or something along those lines, which aims at running that frontend in parallel so that you can get parallel compilation even if your dependency graph is not composed of tiny small crates. So probably something to discuss after this interview. I can give you some pointers on how to try that out. And I know they're looking for feedback, so yours is one of those use cases. Because I do understand that refactoring a giant code base to be nice and modular and broken down into small crates, it's tough. Especially because when you have, at least I don't know if that is your experience, but when you have one giant crate and that auto import is so easy, like those modules relationship tend to get like entangled over time.
Yeah, I don't want to look at that graph now.
Anyway, sorry, I interrupted you. So go on. So number one lesson from 3 years ago is broke it down into small crates. Your future self will have compilation.
Definitely like embrace like automation like as much as possible. Like this is probably more related to like release process. Mm-hmm. So we're still finding our way like around this like for our internal like release process, but also our CLI tool, things like that are all open source and they're all like being distributed like through GitHub releases, and it's a bit clunky with regards to like how we do things, like just a bit homegrown. So I saw this talk about the distribution is hard, kind of like talk, and I'm not sure what the exact name was anymore, but that was really interesting. Like it's just like, oh yeah, if people have to like really deal with like trying to install your application, they're not going to do it. So that's like, oh yeah, that's makes sense. Like if you go to the release and you see X_ Mac, blah, 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 there will be like, Linux.
It's like AARC64.
Yeah. They'll be like, what the hell is this? And that's like, oh yeah, that's true, right? Like I've also had the situations where it's like, yeah, I need to download it, chmod it. Oh, that seems like a deal or like a hassle, like whatever. So distribution in that regard is also like one of those things where I'm like, yeah, we really need to improve there. So I'm also looking forward to maybe spending like a hack day. A hack day is at the end of the month where we get to just like work on something related, like loosely related to like the product or the development or whatever. Like obviously you're not gonna knit the whole day or whatever, but I'm looking forward to like spending like an afternoon or something, trying to get that in, see if that improves things and how easy it is to use. So yeah.
So for the folks who are listening, the talk he's referring to is the one from Ashley Williams, which happens to have been published on YouTube literally like a few weeks back. So you can find it. And the tool you probably want to be checking out is called Cargo Dist. And it generates automatic installers and downloaders and all the circuits that you need for distributions for Rust binaries and not just Rust binaries. And it's quite cool. I'm trying it out as well on a few projects, and it's very, very promising. So yeah, have a look at that. Well, I guess a different question, which is, not really about your regrets and things you liked over the past 3 years, but it's about what can Rust do for you that it doesn't do today? Like if you had a magic wand and you could make some changes to the language or improve some parts of the tooling, what would you do?
Yeah, obviously the stupid one, like the improved build times, but that's...
it's important to say.
Yeah, and also my own.
It's important to repeat it to cementify that it's a priority.
But it's also my own fault. So I can't only blame that on Rust. Once I see something I really like, how could I have lived without this kind of situation? Like looking back to like Go, was like just talking about it. It was also a bit of a walk down memory lane. It's like one of the things I always like really enjoyed about Go, and to a certain extent also in .NET. That like things like interfaces were always like so easy to work with. Like with Go, if it has like specific functions, it implements that interface by default. And that was just like so easy to work with. Like Rust obviously does it in a little bit of a different way, and it has the generics. Like disclaimer, I have not worked with Go.
With genetics.
Yeah, after they introduced the generics, I've not really looked into that at all. So I don't know how it compares nowadays. But yeah, just being able to just like pass along an object to a function that just happened to implement the same signature, that was always a pleasure to work with. With Rust, like obviously you have like the generic implementation, which I know ironically is more like the .NET days for me. But then also like trying to make that dynamic with like dynamic dispatch. There's always like the little asterisks, the caveats of like, this might not work in this situation, or might not be as you expect it to work, or maybe it might be slower, which is also, I hear a lot of people say, but I'm also like, how much slower can it actually be? Like I'm running a web service, so calling out to the database is probably going to be like way slower anyway. So,
Yeah, there's a common complaint that I also a little sniff about. It's like, I mean, yeah, if you're counting the nanoseconds, it probably matters. If you're counting in milliseconds or tens of milliseconds, which is the order of magnitude that your average API/web server is dealing with, it's not the difference between dynamic dispatch and static dispatch that makes or breaks the bank. But my experience is very similar to yours, and I usually phrase it in a slightly different way. The dynamic dispatch is a very non-robust solution, as in you architect your stuff around like a box Dean object or like an arc Dean sum traits. That's usually the shape it usually takes. And it works. And then one day you realize that you got to add a method to the trait, and then suddenly your trait is no longer object safe. And so now you need to go and rewrite and rework all the code that was taking this dynamic dispatched object to do static dispatch, if you can, which usually can, but it might be various levels of painful. And so it's not resistant to perturbation. Like if the requirements change slightly, you flip basically in a different modality, which is like, okay, this feature is not available to you anymore. Now go rewrite everything else. And that's why usually I don't suggest dynamic dispatch for like what you usually would call inversion of control, I guess, in .NET, which is dependent interfaces, non-dependent implementations, because it's brittle.
Yeah.
I know there are conversations around making it less brittle, but I mean, as of today, it's what it is.
Yeah, it's unfortunate, but I do understand, the reasons behind it. The playing field, it just doesn't lend itself as much to these, to the dynamic dispatch,
That makes sense. Two things. Number one, a lot of the people who are listening to this podcast are either Rust decision makers or people working with Rust, or people are willing to work with Rust. And we touched some of the points that the decision makers might be interested into. So your experience, regrets, things that worked out, hiring, so on and so forth. I want to spend a few words on what people who are looking for a Rust job might be interested into. So obviously Fiberplane is a company using Rust. You have hired Rust developers in the past. If you were to give out advice to folks who are looking for the first Rust job, what would that be? What do you look for when you are examining a prospective candidate in a position that has a heavy Rust component? Is that any different from what you would look for in a different language?
A knack of the language is very important. Like programming in general, I think it's important. But if you want to like land a Rust position, like you have like zero Rust knowledge, like the Rust book is a great tool to begin with. That's how I started. But then when you do get started, like you do get like confronted by the borrow checker and all of those things. So if you are gonna start with Rust and want to get a job in there, don't just go through like the theory, for example. Like that, just don't start to not just like read about it, but also like try to make like one of the popular tools and just try to rewrite it in Rust, like reading in some data from standard in, reading it out, make like a little web server, something like that. That will get you like so much more knowledge, and you will get like yelled at by the compiler at a lot of stages, because a lot of things which might have been normal in, like, let's say Go or .NET or whatever, like what you're used to, they might not be the optimal way of doing it. And then, if you are doing something wrong with, according to the borrow checker, you're going to get yelled at. And then, it's easy to just clone everything. And then, my tool's working. But obviously that's not really the way to go. And then, like, really trying to understand that, why is it doing that? Or why is it preventing me from accessing this data at the same time? And which maybe even, like, if you want, that's one moment for me was like, it's trying to prevent me from making this security mistake, because then X, Y, and Z could happen. Like stuff like that. I think just like that curiosity, I think is important.
So seeing compiler errors not just as obstacles to overcome, but as opportunities to delve deeper as to why things are the way they are.
Exactly, like a learning moment. Yeah.
Okay, sounds good. Well, we covered a lot of ground today. That was quite interesting. Thanks for agreeing to doing this and coming on board. Is there any closing thought that you want to share with people listening to the podcast?
Yeah, obviously try out Fiberplane. It's going to be cool. But Rust is a very, very cool language, and it really also like reignited my passion for like programming, like making these like small little tools, because it is quite easy to just get started. Like Rust up, getting the tool chain installed is just so easy. It's really great. And then trying out something, just having one tool, one cargo fund. Yeah, it's a lot of fun. More Rust developers, the better. Yeah.
Nice. Well, thank you for coming once again. It's been a pleasure. And that's all for today. We'll see you for the next episode. Bye-bye.